just thinking very briefly at a high level, we launched the Plutus PBL course in July. We've been running live coding most weeks since then. It would be interesting to go look back at the calendar and see how many weeks we've missed since July. I don't think it's many. And at the start of the course, the focus of those live coding sessions was to support learners by doing either live demos of components in the course or opening up Q&A sessions. As people started to finish the course, we've grown a little bit more informal and flexible about what we do during this time. And sometimes there's somebody who's working on a project in the course and we can look at that together. And other times I've taken the lead and just kind of shared out some updates on what's going on with GPTE, for example. What's next starts today. And like I said in Discord, I want to do an experiment, at least for a few months, where we make a clear distinction between what typically happens on Wednesday versus Thursday, where Wednesday is a chance for anybody to share about something they're working on, and Thursday is a chance for us to practice governance by looking at the current list of projects listed on the GPTE and making sure we're happy with what's there. Right? My goal is for everybody who has a contributor token to see something on that project list that they're excited about contributing to. And that won't happen right away, right? We're going to have to iterate on that, but we're going to get there. So the context of this, I think it's important to name that this really is governance work. Participating in Catalyst from the early days, I've come to understand that, to have a robust governance system, you need leadership and decision-making. And so I want to focus on the leadership part on Wednesdays and the decision-making part on Thursdays. By having a chance to present on the things we're working on Wednesdays, I hope that we're building up leaders, right? I hope that after you see this presentation today from Saurabh, you're gonna look to him when you need his help, right? And get that expertise. Next week, we'll have Hinson and Alex talking about the CBOR automation endpoint they built. And they're going to be authorities for all of us, including me, to refer to when we need help on that stuff. Additionally, remember that as people start working on projects, some of the projects have an approval process where you have to bring your work to live coding or elsewhere and present it. So I think this Wednesday schedule is just going to give us a natural place so that when somebody does finish a project that requires the live group approval, we're already going to have this system running of bringing people together like this on Wednesdays to look at the project that happened and then decide collectively if that thing is done. And that decision-making involves some work. We're going to iterate on that too. But just like all of this, right? We're building these systems. We're starting now. Thank you all for being here to initialize these systems right now. I'm fully confident that we're going to look back on what was happening right now, a year from now, and say, look how far we've come, right? Look at what these leadership and sharing sessions are. Look at what these collective governance sessions are. So that's where we're going. So before we jump to the main event, anybody have questions about any of that? Okay. My job I'm hoping to have this done by Friday, but things are kind of wild right now. But certainly by next week, I will have a written version of what I just said for everybody to review. And then we can iterate on that after people have time to think about it. But let's jump in. Let's do the live coding part. So, my friend, Saurabh, what's going on?
Let's go.
You built something dope, and I'm so excited that we just get to look at it together today. Screen sharing should be enabled. Take it away.
So, okay. Am I screen visible?
Yeah, it looks good.
Okay. Okay. So we'll start with the live demo of the site so we can sort of understand what this is all about. Okay. So first and foremost, there is this connect button here, and aim is to, it is serving two purposes, which we will see shortly. One of them is to select the wallet. Okay, so I'm selecting Nami. It should also ask me to enable that wallet, but since I've already whitelisted this site, it's already there for me. And this zoom settings are in between my browser. So, okay, here I guess I can just, yeah, now if I refresh this site, now if I connect to my wallet, yeah, it is asking for the access. And then there is something known as session password. We'll see its use later. So good on this end. Selecting a game. Now to enter the second player's address, the stake amount, the move duration, and any move. So submit. So since the stake amount, which is basically the bet amount, it's 30 ADA plus some fees.
Before you sign that, can you, oh, never mind. Can you show us the details that show up in the Nami wallet, for example, as well?
Yeah, so since this second player would also be putting his stake amount, so maybe then we can see, is that fine?
Perfect.
Okay, so join an active game. By the way, I went here in this join an active game involving you. So no games found. So currently the move is not yet fully reflected in this blockchain. Still no. And also, in case the first players, for some reason or the other, say the game abruptly stops, maybe the system went off. So in that case, it is also possible for the first player to recover this game, provided the password was known. I mean, the password was not changed by the first player. So if he's using the old password, then he will be able to recover this game. I'll also see show that. It's just that it's taking quite a long time to reflect on blockchain. Usually, okay, finally it's here. So first of all, there is no server inside this whole application. Everything, I mean, the main database is the blockchain itself. So all this data, the first player's address, the second player address, the game stake amount, game start time, move duration, etc., is being derived from the blockchain itself. And as I mentioned, the first player's move is not known. I mean, it's not given to the blockchain, but still here, if I show the data for the first player, there is this entry your move. And the first player is able to sort of say decipher his move. He has not given his move in the raw form, but in an, you can say in an encrypted form. And the first player can decrypt it to get its move. Okay, so here we were. Now, since the seconds are almost done, so we won't be able to see the second player making the move. So for that, Nami signing the transaction part, I can show the for the first player, so we can see it there. So since the timer is done, the first player can get its funds back. So if I click on it, I should be able to get my funds back by signing the transaction. Although I hope that there is no issue, I mean, the deadline has just gone off. So I wonder whether my system clock is, yeah, it's not, I mean, there is this deadline. So the second player has to make a move before the end of that deadline. And I just, and my system clock has to be, completely synced with that blockchain time. So if I wait a few more seconds, I should be able to get my funds back. So there is this difference of few slots. Although I have only recently started seeing this issue. In earlier versions of Lucid, I could see this issue, but in between there was no longer this issue. So let's see now if it works. Okay, so now it works. And shortly after, when this game session won't be able to see any UTXO at this there is this thread token which we will see now. Then this will be the second player's window will also show that game has ended. This same window, game is completed. And regarding that, what James was mentioning regarding the NAMI data, see, so this is also completed. And the way this is working, initially it could see a UTXO at that validator involving this player. But now since that UTXO is no longer present, so it is showing that game is completed. And it is making use of thread tokens in this second window to determine that. I will show that shortly. Oh yeah, so James, here, this details, right? You were saying?
Yeah, I always like just seeing what's here. Thank you.
Yeah, so there is this asset, the NFT asset. So yeah, we are minting also. And then this is the quite a long row transaction. Okay, so I think, so I can just cancel that for now. And now we can start by seeing a simple part, which is the minting part. So the idea is there are these two players which are playing the game. So, and this game will have different states. So suppose there is this state A, where the first player has made a move and the second player has not made a move. And then the second player makes a move and we reach some other state B. So where both the players have made a move. But how do we know that whether this state B is linked to state A? I mean, how am I able to chain the different states together so that I don't want some other person to come in between this game? I want all the different states of this game between the two specific players to be linked so that some third person doesn't come in between and add some modifications. And for that, we are using a NFT. So this NFT is having a unique currency symbol. And therefore, once I have entered this game, I know this NFT, and all the different states of the game will be obtained with help of this NFT. So does anyone have any doubt now regarding the use of NFT? It will become more clear as we see the code, but the main idea is this only, to link the different states of the game together.
You used the term thread token a few minutes ago.
Yeah.
That's the NFT right here, right?
Yeah, that is the NFT. So I'm mentioning this NFT as a thread token. So this I'm calling it a thread token because it is threading my different states. So this arrow is like a thread through these different states of the game. Okay, so anyone having any doubts? Any other doubt? All right, so we can start by looking at this thread token contract. So since it is very short, so let's begin with this. So the aim of this thread token, as I have mentioned before, but how do we do it? We are minting this token in the start of the game. And once we have reached the last state, when the game is about to end, I am burning this token. So this token gets minted from in the start and burned in the last. So there are two actions. So this is my redeemer. This line right here is my redeemer. So there are two actions. One is to mint a token and the other is to burn the token. And this is a parameterized contract. The reason being, and the main parameter is this TX outref. The idea is, as we know, the parameterized contracts, once I give them the parameter, then their address, the final hash of the raw code, the compiled down code, since I mean, it depends on the parameter. If I change the parameters value, I will get a different row code in the end. And this TX outref is as such unique. I mean, this is a UTXO. A UTXO is having its unique identifier. So this transaction reference, which we see, I mean, whenever you query a transaction hash in a blockchain, so that transaction hash is this TX outref. There is one more thing, the index. So transaction hash with the index is this TX outref. So, I mean, if you want to see, we can see the documentation also. Yeah. So it has this hash and the transaction ID. So, I mean, in Cardano CLI, whenever we do the query of an address, we get this thing along with an ID. I mean, a single transaction has different UTXOs. So among them this. So this TX outref is the combination of these two. And since this, okay, so once I have given this, when I'm minting, I'm checking this parameter, which I have given, this TX outref, whether is it being consumed in this transaction or not. Basically, there is this transaction which is minting this token. So if the transaction is consuming this UTXO, this ORF here, then I'm minting. So this TX outref is just that. And the idea is, since this TX outref is different, I'm getting a different currency symbol. So the currency symbol is the hash of my compiled down script. And since it is parameterized by this unique identifier, each time I'm using this different TX outref, I'm getting a different currency symbol. So that is how I'm getting an NFT. NFT, if it has a different currency symbol each time, so it's unique. Okay, so this mint case, so in the mint case, I'm checking whether this UTXO is there, which is given by this ORF, that ORF variable here. If it is there, I'm allowing the mint of one value exactly. And in the burn case, I already know these two parameters, TX outref and token name. And if the redeemer is saying burn, so we are just burning it here. So this info variable is obtained from the script context, has UTXO. We are just checking whether among any inputs of this inside the information of this script context, whether any of that matches with the given ORF. Okay, so this must mint amount is just to check that mint amount. And how do I check? In the script context, there is this field known as txinfo mint, which contains the list of all the mints in a given transaction. So if one of the mint is having my token, so there is this helper function known as own currency symbol inside Plutus. So this is not defined by me. It is not defined by me. It is inside the Plutus itself. So you give the context here. It gives you your own currency symbol. So for my currency symbol and the token name, although I'm using this parameter token name, the idea is to have this script general enough. So even if I want to give, so for this game, the rock paper scissors, the token name is RPS. That is my token name. But if I want to make some different game, I would give it a different token name. But the NFT properties are not dependent on this token name. It is mainly making use of this TX outref. Okay, so yeah, so this is that NFT part. And one more thing regarding this NFT part is also that I'm verifying. So this thing here, when you are joining a game, so the way this works, the joining game part is that I have this validator, and inside this, this validator is of that rock, paper, scissors game, the main game. I have the validator for that. So it queries all the UTXOs present in that address, the validator's address, and it checks whether your address is given in that datum, but it also checks whether the token involved in that UTXO is an NFT or not. And how can I verify whether a token is an NFT or not? The idea is I'm using this, basically the property of the hash function, that hash functions are one way. The good hash functions are in generally one way, and somehow, yeah, it's not okay. So one way plus, I will also explain this both terms. It should have this strong collision resistance property. So yeah, so the idea is one way hash function means once I have obtained the hash of a given input, it should be, suppose if I can type maybe here, I have this a variable and I obtained its hash. This d I'm using to say digest. So if somebody is given this d of a, the digest, it should not be possible computationally infeasible to get the a back. So that is the one way thing. So that explains the one way. And the second thing is it should not be computationally feasible to have two inputs, say a comma b, such that they map to the same hash. That should not be possible. So if my hash function is having these two properties, okay, and so the way I'm using this hash function to determine whether a token is an NFT or not, we have this policy, right? Our currency symbol is obtained from this policy, and this policy is parameterized by this transaction reference, right? In the datum of the UTXO, all this information is there: the first player address, second player address, etc. In this datum also, I'm storing this initial TX outref, which was used to mint the token. So like if I show here this token or ref, that TXORF basically. So yeah, you can see the type TXORF. That information is also stored in the datum. And how I'm using that in the Lucid. Okay, I will not go that there now. The idea is once I give to this policy the transaction reference and this token name is rock paper scissors, I should be able to get that currency symbol, which is mentioned in that UTXO. So these game states are having this NFT token. So this NFT token is having a currency symbol. So once I know this TX outref, etc., and if I serialize this policy, this make policy function, by giving it this TX outref, I should obtain that currency symbol, which is this same currency symbol which this NFT belongs to. If that is the case, then indeed this was an NFT which was obtained this way only, using my policy script. Why so? Because it should not be possible to find some another TX outref due to this strong collision resistance property. And since hash function is one way, the TX outref which we have in datum could not be obtained otherwise. So I hope this part is clear, that how I'm checking whether this token is indeed an NFT or not. And this is this implementation here. I'm using Lucid here because it had at the time when I started working on this project, the Lucid had the support for parameterized contracts. The idea is I obtained the low-level seaboard code, the Plutus, the core code, without giving it the actual transaction reference and all, and I serialize it in the in the here. Okay, let me show that. So pages, gains. Yeah. To mint the NFT, I need this transaction reference, and which transaction reference to consume. Now, this is also is a question that among, since when you are minting the NFT according to this script, you also need to tell the TX outref. So which UTXO belonging to your wallet should you consume? So I'm just taking that one, which has the least number of assets. So I ideally want it to, the UTXO to have only Lovelaces inside it. So it should have the least number of assets. And in case there is a tie, take the one with most Lovelace. I wonder, take the one with most Lovelace. I wonder whether there could be a tie there also. I just thought of that. So this function is there, get desired UTXO. So it's just doing that same thing. I want to take the one with least number of assets, and in case of tie, take the one with most Lovelace. So that is how I'm getting this TXORF. So this get desired UTXO is that, and now I have it. I can obtain my minting policy. So to obtain my minting policy, I give it that desired UTXO and my token name. So that was also the parameter, and my token name here is this RPS. And how this get minting policy function works, it takes that low level code. So where was it? Yeah. So this is what it is taking. So I obtain this, but I do not give in this the actual OREF NTN that I'm giving with the help of Lucid. So I have this low level code, and I'm using this function known as apply params to script. So to this function, I give this low level code, and then I give the Zoom is interfering. I cannot see actually. Yeah, now I can see. Yeah, so to it, I give this TX hash, which is obtained from my UTXO. So this UTXO is having the TX hash plus the output index. That is what I'm giving as a parameter. And the second parameter is this token name. And this will give me that final minting policy script code. Okay, so I'm just returning that here. Okay, so this was that NFT part. So this, and also one more thing was there. Where was it? Yeah, so how do I verify the NFT? So in the datum, I'm storing that information. So from the datum, I'm getting that TX transaction hash, the transaction ID, which we used. I showed how I mean, initially when generating this game, we got that desired UTXO. Yeah, here. So that is what is being used. Where did I? Yeah. Okay, so that I stored in the datum also. So I get these information here, and then I again get the minting policy using this TX hash, the TX index, and of course that my token name is same. And this policy, I mean, okay, so first I get the serialized script, and then from the serialized script, I get the policy ID. Lucid has a function for that. So if that matches with the thread token, which is inside that given UTXO, that means that yes, indeed, this was the NFT obtained using my own script. So else I'm returning false. So okay, so this I hope this explains it in the high level, the NFT part. So if anyone has any doubt, I can elaborate if something is not clear. So does anyone have any doubt? Maybe I was going a bit fast.
I'm definitely glad we're recording right now. Because there's a
So
couple of parts,
it,
I want to slow down on. But yeah, dude, you're
yeah.
doing great. You're doing great. Very
Mm,
good.
yeah, it's yeah, I can understand. I also like it that way to see it calmly, the different aspects. Okay, so yeah, so this was the idea regarding the NFT part. And now let's move on to the other part, the main game. So how are we handling that? So the player A, you can call him Alice. So the player A needs to uh, needs to make a choice of a move. So instead of revealing the move, what so if suppose this move was rock, so if the move is given as such, then it is recorded in the blockchain and anyone can therefore see. So the Bob can see that yes, since the move is rock, I'll make the move of papers. So that is not what we want. So we want to hide this move of rock. And how do we do this? There is something known as commit reveal pattern. And the idea is here, instead of giving this rock move, what player A does, it has this random string, a random number string, okay, a string of random numbers. It concatenates that with the move. So it concatenates it with the move and it gives the hash. So I can just write h. So instead of recording in the blockchain the move rock, the player gives a random string plus rock and its hash. As I mean, this is what the player A gives. Okay, so okay, then the Bob generates his move, say rock or whatever. Then the player A, now since Bob has made the move, now the player A can reveal his move, but he must prove that, suppose if this was what the blockchain and Bob can see, this hash of random string plus rock. Now to reveal that the move was indeed rock, the player A reveals these two entities, this random string R and rock. So okay, so this is what A reveals later, the random string and the rock, I mean, and the move, so that the Bob can verify that yes, if I take this random string and concatenate it with the given move rock and obtain its hash, this indeed matches with what was given before, right? So that is the idea. So the idea is the first player first commits to the move. How he commits? He takes some random string plus the move and hashes it, and then the player B takes the move, because there is no way for this player B to determine what was his move, because it should be impossible. So you should take this random string to be, I mean, 32 bytes, I think that's 256 bits, yeah. So this random string should be that long, so that it's impossible for Bob to iterate over all these random strings and to see which of them, I mean, the second thing, the rock, there are only three possibilities, either rock, paper, scissors. So iterating over the move is easy. So, but by making iteration over random strings, so the possible number of random strings, since if it is a 256-bit long, is very difficult. And therefore, Bob will not be able to know what is this random string, and therefore it won't be able to know the pre-image of the hash. So the hash function we will be using should be a good hash function. So the Bob will not be able to know the pre-image. So that is the main logic of commit reveal pattern. Like if anyone has, does anyone have any doubt here?
Hey Saurabh, this is Surajit.
Yeah.
I have a question. Uh,
Mhm.
you mentioned this concept of a thread token.
Yes, yes.
Uh, so is it like a session variable that you
Yeah.
are?
I mean,
Okay,
each game will have a different thread token.
okay,
So each game will have a unique NFT because,
okay,
yeah, I mean, in the start of the game, suppose this move where the first player makes his move. When doing this, when making the first move itself, I will mint this NFT. And once and whenever there is the last move, a move which is going to a terminal state, I will be burning this NFT. And how this NFT is unique? Because each time the first player, when he's making a move, a UTXO, the input UTXO, I mean some UTXO of player A would be consumed. And since
okay,
a different UTXO cannot have that same transaction hash, it would be not be possible to have a different currency symbols. I mean, the same currency symbol should not be possible. And we can see that here. That's a good place to see this also. So this is the thing. So Lucid, new transaction, collect from. So I'm collecting this UTXO, whichever you have selected for minting the NFT. Since the NFT is parameterized by a UTXO, so you need to consume that UTXO. I have my own logic to consume a specific UTXO. So
yeah,
this collect from function is making sure that yes, I collect this UTXO. And then I am minting this NFT token. So this unit is obtained from that currency symbol and token name. So this unit is just that string, currency symbol token name. And this 1N is just saying one, I want to mint one amount. And then this data.to is, I mean, this part right here is basically the redeemer. So the redeemer here, when I'm minting the token, is this mint part. So this mint part. So this is the redeemer. So I mean, yeah, so that's mint. And then I'm attaching this minting policy. This minting policy is obtained by serializing. So I had this policy, right? It needs these two parameters to become serialized. So these two parameters were obtained from this. I mean, the token name parameter. This parameter is RPS, a string RPS, and this ORF is this UTXO, this desired UTXO. So this minting policy was obtained there. And then I'm paying to this contract. First of all, what I'm paying. So this is the first, I mean, this part is when the first player is making the initial move. So when the game is being created. So in that, this Lovelace, basically it is this only, just a shorthand in JavaScript. So this Lovelace is that stake amount. So when generating this game, we are entering a stake amount, right? 30 ADA, 300 ADA, whatever. So this Lovelace is that stake amount. And then to the game validator's address, I'm also sending this thread token, which I have minted. So this is being minted in this transaction and being sent to this validator. So I'm paying to this validator the stake amount and the thread token and the datum. This is like the very important part. So this datum is inlined. This datum is inlined. I mean, the datum holds all the information such as the first player address, the second player address, and like that. And one of the thing is that throughout this game, some of the things don't change, such as the first player's address, second player's address, the stake amount, and what is the start time, move duration. Basically, the start time is the whatever the time your clock is giving when you are creating this game, and this move duration, if I'm putting it as 3 minutes, so the game start time plus 3 minutes will be the deadline where in which the second player must make a move. If the second player doesn't make a move, you will be able to get your stake amount back. And in case the second player has made a move, then your deadline will be the game start time plus 6 minutes. So twice of whatever you put here. So it's also mentioned in this popover note. So once the second player has made a move, you know your deadline. You know your deadline beforehand when creating this game. So that is the idea. So you must make a move before that deadline. So that
So
is
each move is a NFT.
can you repeat?
So each move is an NFT. You're storing it as an NFT so that
No,
it remains unique.
each move is not an NFT. I am minting the NFT in the first move,
Okay.
but all the other moves will be carry forwarding, putting forward that same NFT token.
All
The
right.
idea is, okay, so when making the first move, when generating this game, so suppose this was the new game, I mint new game. So in new game, we mint. I am minting a token. Okay, the NFT token I am minting. Now, whenever the other players, all the other moves will be simply taking that will be simply consuming. Suppose I'll make it like this. This is your validator address. I'm not able to write here that properly. So this is your validator address. This is having this UTXO. Okay, this UTXO is having that NFT, right? And now the first player has made a move. We are seeing this UTXO having this thread token, this NFT, and now the second player is about to make a move. So second player will consume this UTXO, which is having this which is having this thread token, and then it will add its own UTXO to this validator address having that same thread token. And now the first player, since the first player knows this thread token, I'll just write it as NFT. So now the first player already knows the currency symbol of this NFT. He is able to determine that yes, this is indeed the correct game that I am following, the game in which I made this move. So NFT, with the help of NFT, this same NFT, throughout all the different states of the game, the players know what they're dealing with, what game session they're dealing with. Suppose you and me are playing one game, we are having an over NFT, and in another browser, you're playing a game with some other person that is having its own NFT, and the game between you and me and the game between you and somebody else don't interfere in between. And the reason they don't interfere between us is because they are having different thread token. So
okay, I got it now. Thanks. Great presentation, by the way. Great
thank
work.
you. Okay, it will become actually more clear once you will go through the code. Yeah, and okay. So the game, this validator contract inside, there is some information which is same throughout the different states of the game. For instance, the players' addresses, they are same. The stake amount, start time, move duration, and these are some stuff. This stuff is something I will explain later. And also the currency symbol. This is basically telling the currency symbol and the the transaction which was consumed to generate this NFT tokens currency symbol, right? So this is same throughout the game. So a choice was there to make this game contract, this validator game contract parameterized. But if I make this contract parameterized, then whenever I'm giving the different parameters, and each game will indeed have different parameters, that means for every game, I will be having a different contract address, and therefore I will need to communicate. Suppose the first player generates a game. Now this game will have a different address. The validator address will be different. So how will you first tell the second player this new address? So this is one problem. And the other problem is, since the address is changing every time, we cannot make a use of this versatile feature of reference scripts. So what I decided is that I will not parameterize this, even though the information is same throughout the different states of the game. Like some information is same throughout the different states of the game, as I mean this game params data which I have, this game params data, whatever is put inside it, that will remain the same for the throughout the game, the different states of the game. But even then, I'm not parameterizing my contract with this thing because I want to make use of reference scripts to have low transaction fees, and also so that I need not communicate to the second player this new address. Now, since the address is fixed of the validator, the second player already knows to from which address he needs to query the different UTXOs to determine which of those UTXO is having a game involving him. How does he check, by the way, that? He just queries all the UTXO inside that validator and sees whether it checks whether any of these two addresses matches with his. So in case any of these two matches, then he knows that yes, this game is belonging to me. So if we start, so I think it will take some time to go over this validator contract. There is, before I go over this validator contract, it's also quite simple. Like if you go over it, it should be able to understand. I would like to explain another idea. The idea of this, that once I like connect, select my wallet. What is this? Session password, right? So this is a good idea. And the thing is, we saw that when the first player wants to make a move, he needs this random string. And suppose with the help of browser, the browser is generating this random string. Then what the player A, Alice, will need to do is that she will need to write down this random string somewhere to keep it safe, so that later when she has to reveal what this random string was, she will be able to do so. But this adds inconvenience, right? Like asking the end user to store some random string. And if your game is such that it requires multiple such moves, so each of those moves will have a different random string. So therefore it becomes tedious and therefore not convenient for the end user to store all these random strings, right? And the way I have circumvented it is that the player need not keep track of this random string R. What I'm doing is I'm asking Alice to create a session password. So Alice creates a session password, and whenever there is a need of this random string, she simply encrypts this random string R with the help of that password and store this encrypted random string in blockchain, in the datum. So this encrypted nonce is basically that. So in the datum itself, this encrypted nonce is there. So Alice is just storing this random encrypted form of this random string, and when she wants to recover this random string R to reveal it later, she can just look at this encrypted nonce, this encrypted random string, and decrypt it with the help of this same password P. So if the user has set this session password, so just by having a single session password, we will be this random string R is generated with the help of browser. There is this web crypto API, as it is called. So with the help of this web crypto API, I'm generating random numbers each time. And so user need not remember these random numbers because they are stored in the blockchain itself, but in an encrypted form, encrypted with the help of this password. And there is this algorithm known as PBKDF2. I think it starts, the issue is whatever encryption algorithm we are following, usually you will see they require a key, the encryption key, right? Here I'm saying that my password P is the encryption key, but actually the encryption key should be of fixed size. So usually we will want the encryption key to be 256 bits long, right? But your password won't be 256 bits long. So there is this algorithm known as PBKDF2. I think it stands for password based key derivation function. So using the password, it will derive a key. So whatever password you set, I'm having some conditions on the password that yes, it should be of this much minimum length, capital letter, small letter, symbol, number, etc. So whatever your password is, it will use that password to generate an encryption key for your encryption algorithm. So this PBKDF2 is requiring two parameters. One is, I mean, this is something we need not get into, but you can look into it if you are interested. So these two parameters, which is this initialization vector and the iteration. I'm also having this iteration count different. I mean, the thing is, okay. Yeah, this line here. I mean, this is a parameter for PBKDF2. We need not go into it, but I'm just saying that this is random for my application, because making it random makes it more secure. So since it is random, I'm storing it is in the inline data. Okay, so whenever we want to decrypt this nonce, we need to generate that key, and we will be able to generate that key using these two parameters. They can be public, no issue in there. And my encryption algorithm also requires something, this initialization vector, and that is also being stored here. And this can also be public, right? So I think, yeah, that covers the this part, the session, create session pass. And if you want to read more about these two parameters, you can look at the GitHub code. There I have explained what is my choice of these two parameters. Okay, I mean, how these two parameters are generated. So a mechanism is given there. Okay, so I have covered most of the the main stuff, important part. And James, are you there?
Yes, sir.
Yeah, so we are reaching 9 p.m. I mean, so the 4 UTC time, 4 p.m. UTC.
Yep.
So should I should I explain now this validator contract? I mean, this rock paper scissors contract.
Yeah, so we've got 30 minutes left before we have to run. I have to run from this meeting, and I'm sure it's getting, as you said, it's getting late for you.
No, it's fine for me. Maybe, I mean, if I remember correct, it was supposed to be till this time, right? The 4 p.m. Is it not now 4 p.m.?
Usually we end 30 minutes from now, whenever that
Okay.
is, would be standard.
Yeah, I think it's also not 4 p.m. 4 p.m. is yeah, I think 30 minutes are left in that too. Okay,
Okay.
that's great. Sorry.
You're
Okay,
good.
so this is the main contract, the rock paper scissors contract. So we can look into that. So module, this contract, it is exporting some stuff. We will see all that. These are the imports. We will see use of them. Okay, so the first data type, which is the move. Okay, so what is the move? Rock, paper, scissors. What is your move? So this data type is for that. Then I have to write the equal instance for this. I think the main reason why I'm not doing something like deriving equal, I think that's because we want it to be inlineable, and by default it's not. So to have an inlineable instance of EQ, I'm writing my own instance for that type class. And why do we want it inlineable? Because everything inside this make validator, whatever you put, has to be inline. I mean, there is this template Haskell stuff. Where is it? Yeah. So everything inside it has to be an inline. I mean, all the code should be present inside here. And how will that be possible if it is inlineable? I mean, inlineable doesn't guarantee that it will be inlined, but it's, wait a second. Yeah, I mean, but it will be inlined here. So I'm deriving the is data index. So to be able to convert my custom data type to the built-in Plutus built-in data. There is this data type built-in data in Plutus. I guess you all are aware of it. So I'm just making it that, but giving it my, I mean, I'm specifically giving the index for the different constructors of this data type. And we have the data type for the match result. So either the first player win A, win B for second player, and draw in case the match was draw. And I'm again deriving the equality index for this. And also the is data index for that. And then we have these game parameters. I have covered that. And I'm also deriving an equality instance for this. And we will see why are we deriving the equality instance for this game parameters. So we'll see that. And also the is data derivation is there. And then the game datum is having these game parameters. Okay, so one thing which is present inside the game datum is these game parameters. And now the first player's move. So initially, I mean, when the first player is making the move is this random string concatenate with the move and the hash of that. So this built-in byte string is telling that, okay? And then when the first player has made a move, the second in that point of time, the second player move is not present. So that is why it is maybe here. So initially it will be nothing. And match result is also not determined as of now. So that is the idea. And once the first player has revealed, I mean, when the first player has revealed the random string and the move, then this entry, the first move, will contain that move in the original raw form, not the hash. So initially it is the hash with the random string, but once the first player reveals that random string, etc., I'm using the same entry to tell what the move was. Okay. So we can look at the redeemer case. So once the first player has made a move, then the second player has the choice to make a move. So this B move is for that choice. So that is this redeemer. And then once the second player has made a move, the first player will reveal the random string. So the first entry, this built-in byte string, is for that random string. And the first player will also reveal the move. So this move right here is for that. Then in case once, I mean, when the first player made a move, the very initial move, the game generation move, in case the second player did not make a move, so if the timeout happened, then we have this B timeout take a case. So the A will take the funds back. But when the second player made a move and the B, once the second player has made a move, but A did not make a move in that deadline, then this A will take the B is entitled to take the funds back. So this redeemer case is for that. And we will see the draw case, and this A is idiot case is when the A lost, but suppose the first player made a move, right? And the second player made a counter move such that the second player won. Now, the first player, the best possible action is for the first player to not make a move. Basically, the first player has lost. So either he can prove that he lost, or he can just wait for the timeout thing to happen. If he's proving that he has lost, then he will have to spend some transaction fees. So it is better for him to not do anything. Once the timeout will happen, and the B will know that since timeout has happened, that means A must have lost. I mean, most likely the A may have lost. So B will take the funds. But if A is proving that he has lost, so in that case, B will take the complete money using this action that A is idiot. Okay. So this is the main validator stuff. In each of these states that we had of the game, we check whether the thread token is present or not. So from in the own input, so we can, if you want, look at this own input here. So this is the on input function which I'm having. And this find on input, yeah, it's a built-in function. So whatever the UTXO which you are validating now, that is this find on input. Okay, and so it is maybe, so maybe for, I mean, I don't remember why it could be nothing, but in our case, it would be this just I. So we are just sending this thing. So this on input, if we are right. So in this, in our UTXO, which we are validating, this token is obtained from that datum, that currency symbol. So we want this input UTXO to have that token. So to have that NFT token. And we checked whether this was indeed an NFT or not in the off-chain code, right? In the TypeScript code, we checked that. Okay, so now for the different cases. So in the datum, we had these entries. So maybe I think I can do like this. That's better. And yeah. So in the datum, we had the game params, they are fixed, right? So the three things which can change are these first move, second move, match result, and also we have a redeemer. So in the datum, we are having this first move, second move, match result, and the datum. And this Haskell linter is just saying me to use, I mean, avoid big tuples. Since my tuple size is 4, it is telling me to avoid it, but it's fine here. So so the case, so for all, okay, so let's see. So the case when the second player doesn't make a move. So if the second player doesn't make a move, the first player can take his funds back. So in that case, okay, so second move, this second move has to be nothing. So the second entry inside this tuple, nothing, is saying, okay, the second move has to be nothing. Match result also nothing, which is not determined. And the redeemer is that B has timed out. So in that case, the transaction indeed must be signed by this first player, which is obtained from the datum. And, we don't want people to mess with this datum. So that is why we have our NFT. So I think now it is making more sense, the use of the NFTs here. Okay, so this thing is just, okay, so this G player A, I'm getting the address of the first player. And from that address, which is the combination of payment part and the staking part, I'm getting the payment key hash. So you can look at this function, this get player pcash below. So I think it's not worth going over it now. So I've explained the high level idea. So this transaction must be signed by that, okay, the first players. And also we want the deadline, the second player deadline indeed must have happened. So to the second player's deadline, again, you can, I have like second player move deadline. Yeah, this is how I obtain. So from the game parameters, which is obtained from the datum, I have this inside these parameters, I have this game start time. So I obtain, and from that start time, I add this move duration, right? So the deadline is game start time plus the move duration. And this move duration is in milliseconds, and the game start time is in POSIX time. So I need to convert my milliseconds into POSIX time. Basically, it's just a type wrapper. There's the value doesn't change, just the data constructor is changing. So this from millisecond function is doing nothing. It's the value remains the same. It is just wraps it in different data constructor. So that I need that so that this plus is working, requires both the data types should be same. So both should be POSIX here. Okay, so this is the second player deadline. So 1 plus this second player deadline. So that is how. So this from is basically saying my validity p interval, the interval in which the first player can indeed say that second player has timed out is that from second player's deadline plus 1. So second player deadline plus this 1 millisecond. So this from is obtained from that, like if we look at this header. Okay. So first of all, this ledger.time is I'm using here, and it is v1. There is no corresponding v2 for ledger.time. It's v1 only. So why I'm using this is, I mean, it has not much, so not much is present inside this, and basically for this function from milliseconds, right? So that is why I need this. And then I'm using this ledger.interval, and this is what is having this all this from, contains, etc. So if I want to see that, this is not working. How do I get this? Okay, so V2 API is, I mean, this indeed internally is using this only. Even though it is reading V2 ledger.api, internally it is using this only, v1.ledger. We can see in its source also. Yeah, this v1 ledger.interval. So that is what is being used here. So it is having all these functions, these helpful functions from, to, etc. So from a will just construct this interval. So interval, you know, I mean, we can go into this. So interval is having a lower bound and an upper bound. So each of these lower bound and upper bound could be either infinite. So either this infinite, etc., or they can have some specific value. All right. So basically, I'm just generating this interval from the given deadline. And a player can consume this only when the TX info valid, I mean the transaction's validity period is inside this interval. And now once the first player is claiming his funds back, then the game is ending, right? So that is where the NFT, I want it to be burned. And how am I checking whether this NFT is indeed getting burned? So we can look at that. So in this transaction, in the script context, if we look at the script context, so in the info, we have this mint field. So, you know, in the extended UTXO model, the script context can look at the entire transaction. So inside this mint field, I must check whether, yes, you are indeed burning this token. And that is happening when you are minting the -1 amount of it. Since the original amount was 1, so to burn, just mint -1. Okay, so by the way, we just saw this first case, right? When the second player doesn't make a move. So does anyone have any doubt? Like, please feel free to interrupt in between if something I was going over is not clear. I can also maybe look at the Zoom chat.
It's really, you know, I've seen similar lectures from Lars in PPP about game state, and I really appreciate the insights that you've shared here. Thank you. Really, it's making a ton of sense.
Thanks. Yeah, it's basically extension of that, but I mean like full-blown extension, the complete dApp thing. Okay, so
I had a question about the random number. So if so on chain, the player B can technically view the player A's, whoever made the first move, they can view their move in the hash of their move, I guess, with the rock, paper, scissors, and then their random number. If one player uses the same password over and over again, is it possible for somebody to, will it create the same hash for rock?
No.
Or
Yeah,
is that
no.
what those two PBKH parameters were?
Yeah, okay, I'll just go over that. So the main doubt, if I understand correctly, is over this random string R. So what you want is that this Alice should in each game generate a different random string R, right?
Yes.
Yeah, so I can just go over that.
Is R is the password that they input, right?
No, R is a random string. And
Okay.
how this password is different. This password as such has nothing to do with this random string. What is happening? I'll just show that. So where is that? So, okay, so this is this generate random string function. So this is 256 bits long, and this is using something known as web crypto API. So this window.crypto is obtained from this web crypto API, and that is having this get random values function. So inside this random values function, you give your array, and this populates your array with that random string. So each time you want to create a game, you are using this generate random string function, right? So here you can see it has as such nothing to do with anything else. It is just generating this random string, right? Now, what I want to do is basically, so once I have this random string, right? And in each game, I'm generating a different random string with the help of this web crypto API, this line. Now, what I want is to encrypt this random string. So for the first game, I generated some random string R1, and now I am storing its encrypted value, this part right here. I'm encrypting this random string using that password. So whatever this password was, the session password, this session password is not known. So we encrypt this random string using that password, and now and it is stored in the blockchain so that the player A can just forget about this random string. And once the player A needs to reveal this random string from that blockchain, it is stored in the datum. From the datum, it can decrypt this encrypted value because the player A knows the password. The password is not leaving the browser of first player. I mean, whatever this password is, I'm not storing it anywhere. It's only in the player's browser. And I'm using next auth, next auth, next auth library I'm using for that. Okay, so once okay, the player can using that same password decrypt this encrypted value to get the random string back. And all the different games which the player A might play will have a different random string generated from here. So like, does it answer your doubt? If something is not clear, like
Yeah, that makes sense. I was missing the random string part.
yeah, and you also mentioned about this PBK, PBKDF. Yeah, this is I mean, these are also different, by the way, these parameters, and how like they are obtained. I have mentioned, like, we need not go into this. This is like slightly low level detail. Like high level is that what I just explained. I mean, these two, this part is also important so that your encryption is strong. Okay, so a case. By the way, any other doubt anyone wants to ask? And also one side note that I can mention is that, for instance, this is like if you look at the datum, my datum is having this G first move, which is of type built-in byte string. I mean, this is something related to Lucid. I think it might be helpful to others. So in Lucid, what happens? Whatever the array that you give, this array which I'm giving. So basically, this is an array of elements where each element is having this type, this unsigned integer of 8 bits, right? Now, what Lucid does internally is that it converts all these values inside this array element to their hexadecimal representation. So since it is 8 bits long, it will take 2 hexadecimal characters. So each array element will take 2 hexadecimal characters, and it will concatenate all those characters to generate this built-in byte string. So this is something which the Lucid is doing internally, and therefore I don't need to do this. And by the way, how do I come to know about it? Basically, like if you clone the Lucid's repository and look at the what they are doing inside this data.to function, then there you can see that this happening. So like initially I had this doubt, so I just thought of sharing that. Okay, so the case when the second player has indeed makes a move. So the stuff which we want that it should be before the deadline. So first thing, it should be signed by the second player. So yeah, that thing is happening. And this check that the first player's stake is present is something that is not needed inside the contract. Like I'm doing this validation off chain. So whenever I'm showing the I mean, in this rock, paper, scissors, when we had that second button here, right? Join an active game involving you. So in that off-chain code, I'm checking that whether that game is having valid things. So that the stake is present, the first player stake, etc. Okay, so this part we can ignore as of now. Maybe it's helpful that if I delete this also as of now. So first check, we want that it should be signed by the second player. When the second player makes a move, it should be signed by him. And okay, so initially the UTXO is having the stake of the first player. Now the UTXO which will get generated should also have the stake of the second player. So in total, the stake should be this 2 times whatever the initial stake was. So we are using this own output thing. And if we can look it here, own, okay, so this is this own output. How do I get this own output? And this is where I'm using that equality instance of game params. We had this data type, right? Game params, which was also present in my data. So that we wrote the equality instance for this. So that is being used here. How? So, So get continuing outputs. We can look at that.
And if I can jump in here.
Yeah.
I know that I have to jump off in 5 minutes, even though I can tell we could go for another 2 hours right now.
Yeah. Oh yeah, it's 9. Okay, only 6 minutes are left, right?
Yeah. But so just to put this in context, obviously there are finer points that I think anybody here might want to follow up on. But you've gotten us to the point of, first of all, seeing, this is the second time I've personally seen embedded encryption in a Plutus file. Mix tried to teach it to me for the first time, and I think I understood about 2% of it. And this time I think I was at like 20 or 30%. So it's just, it's really cool to see these tools, like as each of us find new ways to explain these things. It's so exciting. So thank you for that part. Obviously, a follow-up session anytime, Saurabh, thank you. And what I'm really curious to hear from everybody else about is, as you, for example, see that embedded encryption, you see this particular use of a thread or a session token. It was nice hearing Sura kind of make the connection to this concept that has existed before writing in Plutus. I'm really curious to hear what implications people are seeing here from, you know, you make a game and it's playful, sure, but the concepts you're outlining here are essential and are going to be really valuable for really valuable dApps. And I'm excited to follow up on that. And I'd like to, if it's okay, use that as the lens tomorrow, for example. So for anybody who wasn't here at the beginning, or if you haven't seen the Discord message, moving forward, every Wednesday of live coding is going to be a session like this with somebody presenting on what they've built. And every Thursday, we're going to look at the current list of projects in the GPTE. But I'm having new ideas for projects by watching this presentation today. And so maybe as people have a chance to reflect, think about what you've seen today and what you might want to add, and we can start from right there tomorrow.
Yeah.
The last admin message from me, next week, we've got Hinson and Alex presenting on the CBOR Hex automation endpoint they built. And so it'll be really exciting to see that in practice. I just wanted to get those notes in. I will quietly slip out of here in just a couple of minutes. But if anybody wants to stick around and keep going, obviously use the room for that if you want to. And Saurabh, thank you. I'm so excited that we took this step today.
Yeah. All right. So
thanks for letting me interrupt there. I just wanted to make sure to kind of
yeah.
share those notes for anybody who does have to go at the regular time.
So, okay, so about this get continuing outputs, like if you read its description, get all the outputs that pay to the same script address we are currently spending from, right? So once I have all these outputs which are paying back to the same script, ideally there should be only one output, right? We are consuming an input UTXO inside this script address and we are generating a new one. So we are generating actually only one output UTXO inside this script address. So with the updated datum, with the datum of second player's move. So once I have this thing, continuing outputs, among them, I am checking that this game parameters which were there inside. So output data move will get me that output datum. And it will be in the form of that, we wrote that is data instance, right? We were using this make is data indexed function. I mean, this utility. So that is giving us the is data instance of that. So from that is data instance, I want to generate the high level datum, which I had, let me show that. So I want to generate this high level data. So that is what I'm doing. This deserialize function is just helping with that. And the way you do that is just from this function, from built-in data. So there is nothing more towards it than just if and some, some other checkings that yes, indeed, I was able to do it successfully. So that was it regarding deserialized data. And the idea is once I have this high level description of the datum, because it gets serialized when I'm reading from it in an input UTXO, I just get the parameters, the game parameters, and I just check whether they are equal. So this O right here is from the output. So whatever output that I'm generating, so in that output, I want that the parameters should remain the same. So, okay, so whatever the output which the second player is generating, I want that it should have those parameters, those same parameters. So that is why this equality instance is useful. So that is this, and it should have exactly, as I mentioned, only one output satisfying this. So that is this thing. Moving back here. So, okay, so where was I? So I think we were seeing this own output. Yeah. So that is how own output is obtained. And now the datum should get updated. This datum, which was there initially, yeah, this should get updated with the second player's move. So that is right here on I want that. Okay, so first of all, the match result should be again nothing. It should not change. And the second move, which is right here, this second move should get updated to whatever the move which is present inside this redeemer when the second player is making the move. So this move right here, right? And it should be within that deadline. And I mean, it is intuitive. So if you want technical description, you can like read this line, but it is like what it is. And this, and of course, this is the very important check, that the NFT token should be present, should also be present in the output, right? It is present in the input. We also want this NFT token to be present in the output. So that handles the second player's move case. And just 1 second. Okay, I cannot actually see the chat if it's there. Okay. So we did that. Now, once the second player has made a move, so we are like almost done with this smart contract. So once the second player has made a move, the first player has, you know, 3 choices: either he lost, win, or draw. If it is a draw, then he must prove, I mean, if he has win or draw, in both the cases, win or draw case, he has to reveal that random string and all, right? So if it is revealing that, right? So this reveal now, so if we have this reveal redeemer, which is relevant in case the first player has won or it's draw, and if it is doing this reveal thing, even if it is, if he has lost, then, you know, it was not needed. So we want it to be signed by the first player, one thing. Now this is the important part, that we must check this nonce which was revealed, which is revealed now, and the move which is revealed. If I concatenate them, take the hash, they should match with this BS, which is, I mean, the byte string, the first player's move byte string, which we had, right? The initial hash. So that is what it must have. So this check nonce function is just doing that. You can see its description. So also the deadline, we want it to be within the deadline. So it is doing that check here. And now if these have passed, okay, we see what was the match result. If the player has won, then we also want the NFT token to be burned, right? In case it was the draw, now it is important. If it is draw, we want the player to take only his stake amount and leave the remaining, right? So in that case, the output should have the stake amount, and where, okay, this is where that check is there, that in the output which you are generating, you should also put the second player stake. So this is what is being checked here. Instead of checking what the first player is taking from the contract, it is better to check what the first player is leaving behind the contract, because the first, I mean, in this transaction, I mean, the transaction could be more complicated if the player wants. And in that complicated transaction, he might be taking more Lovelaces from some elsewhere, which is not relevant to us. Basically, what is minimally required by us is that the contract, the UTXO there, must have the stake amount for the for the second player. So that is what we are checking, that the own output, basically the output in this script address, must have those Lovelaces, the second player stake. So this is that check. And of course, in case of draw, the token should be there in that output, and the data must get updated. And in that case, I'm also updating this first move. So yeah, this G first move I'm also updating with that move so that the second player can see what was the first player's move. I mean, in the UI, I can reflect it easily. So that is the reason. Okay, so yeah, so the draw case is there. Now, in case he was losing, so he should not have done this reveal. But if he's doing, then again, we just want those checks that the output datum should be updated, token should be there, and the entire stake amount should be present in the game, right? So we are almost done. So in the case when the first player timed out, I mean, the second player made a move and the first player did not make a move in time. So then the second player can get the entire funds back, both the first players and the second players. So there is this. Not much here. Must be signed by the second player. Must be in the after the deadline, and the NFT must be burned. And in case the first player lost and revealed that lost case, so the second player, I mean, just can get those funds back, and NFT must be burned. You can also think why there are, I mean, we need not check whether whether there is any funds left in the contract. I mean, I'm allowing the second player to take entire funds here. And in case it was draw, then I mean, just that the must be checked, must be signed by the second player, NFT must be burned, right? So this actually finishes the entire contract, right? So there was nothing much here. So I hope, yeah, ask doubt.
Hey, Surab, I'm
Hi,
really
hi.
glad that you pulled this off. Really, I'm maybe proud that
Actually,
you
yeah,
did
it
it
was
because.
because of your help, actually.
Oh, thank you. I mean, because
Mm.
I'm thinking this rock paper scissors was supposed to be the mastery level assignment.
Yeah.
When I'm now see it, I think, yeah, I mean, we should have. I'm glad that we didn't put there because that's really great and that's really hard. I mean, I think
Yeah.
people wasn't able to do that, but I'm really glad about that. But two questions. First, the NFT burned.
Yeah.
Can I see the function? I mean, how is that executing inside that? I mean, the NFT burned is.
Yeah, here.
So the
Basically,
NFT burns means -1. How it's
yeah, in this TX info mint field.
okay?
So this holds the like all the what was minted, what is getting minted inside this transaction. So if the negative amount is getting minted, so that means it is getting burned. So I want this token should have the mint amount of -1 inside the transaction. So if it is having -1, that means it's getting burned. So
But when you want to create a transaction, you're actually creating two transactions or not at the same time.
single transaction. So
And inside
just
the single
like
transaction, you are doing the script validation and minting. I'm sorry,
yeah,
burning the.
so we can look at a transaction. Okay, so yeah, this is here. So maybe this thing attach. Yeah, so this is one of a transaction. So what case it is? Let me check that. So first player's option. Okay, so maybe okay. So when I'm okay, so new transaction. So read from. So basically, this is the Vasil feature of having reference scripts. So this read from is making use of that, the Vasil feature of reference script. So I already have, I have put my reference script. I know it's at what UTXO it is present. So these two fields are for that, at what address it is and how many assets it is having. Since it is a reference scripts, it required quite a amount of ADAs to be present there.
So
Okay,
this is the minting script address.
This is the rock paper scissors. So I have this rock paper scissors validator. So I'm
Uh-huh.
storing it as a inside the, I mean, I'm storing it as a reference script. So it is present in the UTXO. At what UTXO it is, I mean, this is that UTXO where I'm putting this.
Okay, so
Okay.
where is your minting address? I mean, the
Yeah,
minting
yeah. So
script
yeah,
that going
let's
to burn that.
yeah, let's go back to that main question. So I mean, this read from thing is just that
Yeah,
there are
that's
two options. Either you can give that give the script inside the transaction. I mean, but if you can read that also as a reference script, so that will consume less fees. So okay, so collect from this is that UTXO present inside that game validator which you are consuming. So first player is signing. So for that, add signer key for the first player. This is some logic for that deadline stuff. I'm adding 1 second here. And this mint asset. So as you can see, I'm doing two things here. One thing is that I'm consuming a UTXO. So this collect from is that UTXO consumption from this validator's address. And inside this same single transaction, I'm also minting the assets. So I'm also using attaching my minting policy. So attach minting policy, and I'm minting this asset, the -1 amount. So this is my
I didn't know that's possible because I thought that if you want to burn a token or NFT, you need to use the same script that you minted at the first place.
yeah. This is that
So you
there are
cannot
two
use another
scripts.
contract to burn that.
Yeah,
So
there
is
are
it
two
possible?
scripts. There are two scripts. One is this, maybe I can just 1 second. Maybe I can just close this for now. So one is this script, the minting
For-
policy script.
Yeah.
Which is having two options, either to mint or burn. So a small script, nothing much.
Yeah.
Mint or burn. So in the single transaction, I'm also reading from a validator. I mean, this game validator, this guy. So from this validator, I'm uh, I'm also reading and consuming its UTXO. So like in a single transaction, we can have multiple scripts, each with its own purposes. So one of the script is this validator script, and inside this single transaction, I'm also having this minting policy script, in which I'm minting the asset, the -1.
So attach minting policy is in fact is the contract. It's minting policy. This is
Yeah,
the
minting
contract.
policy contract. Yeah, this attach. There is also this attach, like dot attach spending validator. And in that case, I have to give the low level code of this spending validator. But instead of giving this low level code, I am using this Vasil feature of reference UTXO.
I see. But
So for validator.
my second question, that was really great. But my second question is, how can second player knows that the UTXO he's playing is coming from the first player? Because everything there is inside the data. So let's say there is a first player, Alice, and there is a hacker. And the hacker was observing these games between them, and now he knows that what kind of information is there. So he can craft that datum, but with his address.
Yeah,
That's
but
like,
just one thing, that datum, whatever the UTXO the hacker generates, it won't have that NFT token. That thread token, it won't be having in that whatever the UTXO the hacker generates. So the second player,
that contract minting address is open source, so we can use it.
yeah, I mean,
the hash of that minting, but the currency symbol of that specific contract, it will be always same, right?
no, I mean, there are here, like there are two contracts. So for the validator, the address is same. Validator address is fixed.
Sure,
There is
always
nothing parameterized here. But for the thread token, it is parameterized by this TX outref. And
okay.
so
And he will use it to generate a token from himself, right? I mean, the hacker, or no? This is
I mean,
from
if the hacker generates a token, then it will have a, since he will need to consume a UTXO to mint. My minting policy is such that it has to consume a UTXO. But if he's consuming a UTXO, it is parameterized by this UTXO, and therefore it will have a different currency symbol. So it will become a different game altogether.
So okay. Now let me rephrase my question. How
Mhm.
second players knows that he's playing right game?
Okay. Yeah. So maybe I'll just. I think I should make it down. Yeah, because that Zoom thing is interrupting in between. So let me just log in.
You know, because for example, let's say that there is a
I understood your question. I'll just explain that also. So what happens is, so let this submit happen. Okay, so this rock, paper, scissors. So this is that button. Join an active game involving you, right? So once somebody clicks on this button, it goes, I understood your question. So I'll just tell you, I'm just telling what happens is that we have this validator, right? This rock, paper, scissors validator. Its address is fixed and is known by everybody. So it's also hard coded in my front end. So where is it? Yeah. So in this address of the game, this button will query over all the UTXOs, right?
Yeah.
When looking at each of those UTXOs, the one of the first check is whether the token involved in that UTXO, whether it is an NFT or not. So that I'm checking whether that token is indeed an NFT or not. And how am I checking? I am like I also explained about this. Basically, I'm using my this make policy. Initially, I'm using the deserialized version of this, in which the token reference is not given, and I give the token reference obtained. I mean, howsoever the token reference was obtained, it is obtained from the datum, but I mean, it cannot be cheated because of the strong collision resistance property of a hash function. So whatever the TX outref which was given, basically, I mean, are you able to understand this part that when I'm clicking on this button, all the UTXOs it queries and it considers only those UTXO in which the token is indeed an NFT. So
Sure, but
first thing,
the NFT that you own, I mean, this is for the first player, right?
no,
Join.
anywhere, I mean, whatever the state of the game be, whatever the thing is, when I'm clicking on this button, what happens is whosoever player, the first player can also click on this button. Second player can also click on this button. When this button is clicked, it queries over all the UTXOs, and one of the first check it does whether that UTXO which it is seeing, whether it contains an NFT or not. So that is the first check. So what I want to ask
The
from you,
hacker will mint NFT and will put
hacker will mint
inside
an NFT using my policy, and that will be a valid NFT considered by this button.
Yeah.
So I will come to that also later. But this part is clear to you, right? How I'm checking this, whether it's an NFT or not, right?
Yeah.
Okay. So suppose I'm the second player. I click on this button and I can see that some hacker has generated a datum in which he has mentioned the second player address to be mine.
Yeah.
So I am keen to consider that game. So second player's address is mine, matches. NFT is there using my minting policy, matches. I am considering that game, right?
Yeah.
So like my question to you is, what harm is there in that if I'm considering that game? Because I'm also checking one thing, because I'm also checking in that game whether the hacker has provided his stake amount there or not.
Sure, he will do, but that's a game. He can win always. Because the second player can always lose. Because the answer is in fact malformed, and the answer is not the answer actually presented correctly, and the answer is always something that the hacker can win. And so that's the thing that
no.
UTXO
First of all, one thing that the secret thing, who is generating the secret is the first player only.
that which is a hacker.
Yeah. So if the hacker is, if the hacker wants to give out the secret, then it's in his loss, not the second player's loss.
No, I'm saying that let's say, I mean, you are checking the first thing that is there any NFT, state NFT or session NFT or not?
Yeah.
Okay, that and the hacker can generate that NFT from its
Yeah.
UTXO and put it there.
Yeah.
That's the first pass. And
Yeah.
second is there the second play address inside that datum or not, right?
Just that when the hacker generates this NFT using my script, it's just one thing to keep in mind that it's a new game entirely. It's
Yeah,
not.
but
He's not interfering in some
sure,
previous game,
definitely.
a new game, and
But-
this different game, whatever the things which he might do, like when I'm clicking on this button, I'm doing all those checks, whether that the stake amount is present in the UTXO or not, and all the bad things in my analysis are harmful for the hacker himself, not for the other player. And all the subsequent moves, like once a single move is seen, all the subsequent moves, like the output, the generated datum, that is like this output datum, a particular game instance cannot be corrupted because the output datum is also being linked. Whether that output datum is there, follows that correct semantics or not. And if the hacker is trying to interfere with it, he's generating a new game altogether.
Yeah, definitely. My question was again, how a second player knows that he's playing a correct game, and the integrity of that datum or those the factor are actually correct, because before the smart contract, you can create whatever UTXO you want and send it to a contract. Now it's inside the contract, we have the power, but before the contract, we don't have the power, right? And we cannot check everything.
Yeah.
But you put two conditions to check that. First, is there an NFT inside that UTXO, or if it is not? And second, is there any address inside that, at the second play address inside that or not?
Yes.
And I think you understand too that that's possible to be created by the hacker too. So he can create that UTXO game just to pass these two tests, but that datum is not the datum your contract expecting. So he's creating a bad game, a malform or malfunction game.
Yeah.
But if the second player tries to interact with that bad game that shows up when he clicks join an active game, then and he tries to play without knowing that it's a bad game, then the contract just won't validate and he won't lose any ADA, right?
Exactly. How do we know that? Because the two things that Saurabh said, it passed. So where is the third one? Where is the fourth one?
One thing I would like to just mention. Once, if you may remember, when I clicked on this active game, I had a big entry, right? A big table type of thing in which all the entries was there: first player address, second player address, etc. So that at that time, I am checking whether all these types in the front end, whether the types conform or not. Like here, that the player A, whether it's of this type or not, address. Now it could be some, let's say, a bad address. So hacker is putting a bad address of his here.
The player is the hacker address, and second player B is the second player. That's
this player B is the second player. Player is the player A. So if the hacker is, first of all, if the hacker is putting bad address here, we won't pick this game.
Yeah, sure.
But if the hacker is playing bad address here, then it is of his harm, and then he won't be able to get funds back. And then the stake amount that is verified, whether it is actually there or not. Start time, move duration, again, first player before interacting sees those two information, and he can only play whether it's in the valid range. And similarly, I mean, like if you try to also for these cases, even like the way I worked about it, I thought like all these different cases, like they're harmful for the hacker himself if he tries to, generate a game with not a good datum.
The thing is, he will create that good data, but the data is there is for his benefit.
Yeah,
So
that is what I'm saying. Like if we
because
try
you
to
are
think,
open
if we try
sourcing your code,
yeah, if we try to think about a datum favorable to him, then what I want to say that there is no datum favorable to him. That is what my, when I analyze this.
so you are saying that he cannot create a datum that will
Favorable to him.
always, if anyone play in that game, always that person lose money, and the
Yeah,
hacker will always be the winner.
yeah.
You know why? Because the second player has to guess the first player, or no? I mean, in your game,
Yeah, I mean the second
which one is
player.
going to guess which player? I mean, first player is going to guess second player choice, or
No.
second
First,
player
second
is going.
player's moves is public. So this maybe thing, initially it's nothing, and then the second player reveals, makes his move. So it's public. Only the first player's move is initially that hidden.
What happens if the first player stores his move as something other than rock, paper, scissors when he sends the initial, the start of
Yeah,
the game over to the
yeah,
contract address?
yeah. Then that he can do. The first player, this built-in byte string,
Yeah, say
that
they
can
put in
anything.
heads or like
Yeah,
it's just
that
something from
they can put anything, but then if the first player does that, then he won't be able to get funds back
got it.
because
Yeah,
in the reveal phase he will fails. He
yeah,
will fail.
that makes sense. Okay.
And also, when I'm querying about of the valid UTXOs, then I won't be able to show that also in my front end. It will come in that there is this try catch, right? If I'm using this here, yeah, I mean not here. I mean, I'm having this datum deserialization part in our try catch block, like here, yeah. So all this datum thing which I do, like I have these functions. If I show, not here, yeah, here I guess. So all this datum deserialization part. So like if you look at this get conster function, so like I'm throwing errors in case it's not valid. It's not complete as of now, this file. I mean, initially, as a proof of concept, I did not implement it like, for instance, this thing, this as string, this type assertion, it does not have a runtime check. So even if it's not a string, it will pass here. So I'm yet to implement a runtime check here. So I'll do that when I get time. So, but I hope I answered the doubt.
Yeah, I mean, as I said again, you did a very great job, and I'm really glad and really proud of your job, both in the front end and the back end, a smart contract. And but the thing that I wanted to point out
Yeah.
was, if you want to go to build the actual dApp, maybe you want to expand this idea or this game to a very actual game with multiple different games. And you need to think about that, Surab, that
Yeah.
a person or a hacker or bad person or whatever, he has Cardano CLI. So he doesn't need your front end. And same thing
Yeah.
happened with Ray Network. Ray Network had a front end, and they were trying to catch all of these errors or malfunction or something or malformed datum with their front end. But the hacker found out the logic of what's going on with their system, which was they were focusing on a staking part of the address, not the payment address. So they were checking just the staking part. and not the payment. So he created a script inside his computer server. I don't know what, wherever it was. And it was just creating that transaction one after, and so on, to just interact with that contract, with the contract, with Canton CLI, not the front end. And it was able to at least extract 500,000 ADA from them. And still, I don't know what happened to them. But the thing is, yeah, I think you really did good job. But one thing that I hope in tomorrow we can talk about that, you created a encryption scheme to firstly generate that random nuance or random built-in or random password, and then using blockchain as a database to extract that and use it inside your front end. And then you are using hashing or hash function inside a contract. But what I'm suggesting, there is a way to combine these two, and using all these validation inside your contract again. So your front end doesn't need to do the creating password or checking the password is same or not. Your contract can do that. I mean, they added on the August, around 3 months ago, they add these 3 functions. We can discuss it later, but anyway, they add these two, 3 functions. I can just, I don't know if you were attended in that session. I was talking about this function. First, you verify ED 25590 signature and ECDCA. So you can create password or messages, but for these, and without the needs for another algorithmic or I don't know cryptographic scheme. You can use the person or the player keys or private key or signing key or whatever to create that encryption. And then inside the contract, you can verify the move, which is the first move, was correct or not. So you can combine those two cryptographic scheme that you provided. And the second thing is, I mean, one of the best advantage of this, which I posted in chat, is you are not bound anymore with the rock, paper, scissors game anymore. Actually, you can expand it to whatever game.
Yeah.
So I mean, even the move can be dynamic. We can discuss it later or whenever you want. But again, I'm really glad and I'm really happy to see that. And I hope, I mean, I will suggest to James to add this session and tomorrow's session to the module 303 actually.
Yeah.
Yeah, really, I think this it will help other students too. Sure, Lucas. I mean, I'm first love. There is no noob question. I am a noob too. I just learned something right now with.
Yes, of course you are.
About that. Oh, really? I learned about that. These two, he created on front end two transactions doing one transaction interacted with 2 different contracts at the same time. I didn't know that was possible on front end at least, but now I'm glad to know. So yeah, I mean, you know, we learn everything, new things. So go ahead, guys.
I just want to, before I put in, I just have a question about something that's showing up on my Eternal, but it may be interesting for some people here. But before, I wanted to ask if, does anyone else have questions for today for Surab?
No, thanks.
I just wanted to say that it's amazing. It's just so nice of them, man. And like, I know, obviously Mix, man, he's going to find it, he's going to make us all like battle test us, make us all stronger. But I just think that I love it. I think it's very elegant. And I learned so much, I knew the negative minting, but I like to see the creativity. in transactions. That's like my favorite part about this, is trying to get a very clean, submittable transaction. I just really.
Thanks.
Saurabh, how would you go about, like, I know the first player address and second player address are needed. How would you go about if you just had like a first player wanting to offer up a game at a certain stake, and then that could be queried in the front end, and then a second player could just view all the open offers and then accept a game at a certain stake?
Yeah, that's a good idea. Basically, we want to show the availability, that whether somebody wants to play a game and have it committed to it, that I will play the game if somebody joins within a specific time, right?
Mm-hmm.
Yeah, that is something like I have to think about, but it's like a,
because I know it'd be a lot of changes in the contract, but like for me, like I'm on the website now, and like if I don't have a friend to test this with or anything, and I don't know anybody's specific address that would play with me, like I could just make an offer and say I want to play somebody at some point.
yeah, it should not
for
be
like
as such
58 or
difficult.
something.
Yeah,
And
I
then
mean,
somebody can come along and pick that. But I know that's a larger lift than it sounds.
Yeah, what you can do here is like make it a list. Okay, so this has to be outside. Wait a second. Okay, so make it a list. I mean, forget that it is a parameters, game parameters. Think of it as a datum, a game datum, and this can be a list. And inside your smart contract, if somebody wants to commit to a game, they will just append their address to this datum. So in the output datum, the generated output datum of a game, you will check that whether the player has added their address to this list and has changed nothing else. So basically, I was also thinking about this problem when, like I told initially to James, like I'm working on another game. So in that game, like I call it a play of dice. So the thing is, there will be a dice roll, and whatever the players committed to a specific outcome, they will win accordingly. And in that, for that particular game, I was thinking how can I make it like open to all. So like maximum, say like maybe like 20-30 players maximum can be present. So in a website, a banner could be there where people can join an active game. So for that, when I was thinking about that, so this making this address a list is what I thought. So I mean,
but sure, how about sharing the transaction ID that was submitted to the contract? I mean, the first player created a UTXO with everything and send that to the contract. Now there is a transaction ID, and if there is if someone wants to play with it, he just share that transaction ID.
Yeah.
And inside your front end, that person can, if there is a join with the game, and inside that join there is a field, and that the second player or whatever player wants to play will submit that transaction ID, and you will query that, and you will find it, and he will commit to that exact game.
Yeah, I mean, it depends like how you are designing the game. For the way I am designing the game is like I'm having it. My website is as such static, in a sense that it can be exported as an HTML and run by the end user. So there is no backend. Besides, I mean, there is only one dependency, and that is providing a node. So you need to provide, say, a block frost node. So that is the entire dependency. So with that model, I will need the addresses. So I will need to have addresses put in the datum itself, because my game will later need to give funds back to those addresses like that. I mean, like my logic is such that, so therefore I will need this list anyways. And yeah, but for sharing, of course, yeah, that would also be needed.
Maybe you can add another step, committing. Like first, creating the game. Second is the committing to game. So the second player commit to that. And that is just updating the data, adding the second player address.
Yeah.
And then from the third step, the actual game start. So just by adding another redeemer or another redeemer,
Yeah.
fine.
A ceremony kind of.
Yeah.
Yeah. Also
For
just
the second game, for
Mhm.
the second game you're talking about, how do you plan on getting a random dice roll?
Yeah, so
chain?
I talked about it
It
like at the very
seems I've thought
starting.
about that. It's so difficult, I feel like.
It is there is a solution to it. First of all, like what we want is a random number generation in a smart contract. And as such, it's not possible for a smart contract in Cardano to generate a random number. You will most likely as such need a oracle to give you a random number. But I could not find a oracle in Cardano which gives that random number. So the solution is, suppose you, me, and Mix. I'm calling Mix. Okay, I think that's
Okay,
fine.
fine.
So you, me, and Mix want to play this dice roll game. So what we will do is that all three of us will commit to a random number. So just like how we were committing to our move, we will commit to a random number. So we will see the hash, not the random number itself. We just see the hash. So you submit the hash with your stake. I submit my hash with my stake. Mix submits his hash with his stake, right? All three of us has committed. We have given the stake and our choice, the dice outcome choice, to the smart contract. And we have committed to our random number. Now what we will do, each of us will reveal our random number. So each of us will now reveal our random number. Since we have already committed to it and have already given our stake, right? If we leave, our stake is lost. So we, each of us, give our random number. And now what the smart contract will do is take the XOR of all three of ours random number, and that will be the new random number, the smart contract's random number. So
I see.
By the way, you can create the XOR function by Surab.
yeah, that is what I thought. That is my idea. Is since the built-in XOR is not there, so I'll just write a simple XOR thing, because each hexadecimal value. So for each specific hexadecimal combination, I will give a output for that pattern match in my function.
You know, I wrote a function for byte string to hex. So you can create, you can send the normal literal string and it will convert it to hex. I don't know where I can show you or I can send you. You can use this concept to create maybe XOR out of it too. It's a recursive loop inside to each other.
That is what my idea was, that for each hex character inside your this big hexadecimal string, so for each, so like so suppose I have two big hexadecimal strings. I will fold towards I will first take the zip, basically make a tuple of each of those characters, and for each of the pairs of characters in those two random string, I have a hexadecimal character from first string, a hexadecimal character from the second string. I'll take the XOR of those. And how do I do that? Basically just write a function which has this, 16 into 16. So
I posted the function inside the chat.
Oh, actually, I'm unable to see the chat here. I'm trying.
Okay, I'll send it to your.
Okay, more, I guess, here. Chat, yeah, I got it. Yeah, thanks.
So this function is going to change, to convert everything to hex, and you can use it, I think, but because inside the Plutus there are something like cons, byte string cons, and XOR you can use it. It would be hard, but empty byte string cons. So there are built-in byte string or string manipulation too. There are there, but how you can pull that out is, but and also the coefficient and reminder, they are coming from Plutus prelude. Don't import it from Plutus, from the normal prelude, because you get error and so on. So yeah, the coefficient and reminder is coming from the Plutus prelude, and you have some kind of a string changing or something inside the Plutus core, inside the Plutus built-in internal. That's the library I take it out. And I think you can pull that out, XOR.
I see. We'll look into that. Also, just one small thing is that, like, how do I generate the datum inside Lucid? Like, I did not talk about this. I can just like all this datum thing. So how do I generate this? Basically, I look at this output JSON. So if I prettify it, let me see if I can prettify it now. And not this. Yeah. So yeah, so something like that. If I put here, wait a second. So yeah, so I can see how the JSON of my datum looks. Basically, this is how the built-in data inside Plutus is. The built-in data inside Plutus, if we have a look. So yeah, this is how it is. The conster, integer, list of data, and either an integer, byte, string, list, map, etc. So this is how our JSON will look as well. So I just see the JSON version of my datum. So inside my compiler, you can look in this code. So yeah, so I just write the JSON for the datum. I look at how it looks. So I just generate the similar thing inside Lucid. So Lucid has this data.to, in which you just give that data in this form. So if you look at this.
By the way, do you check that the datum attached to the UTXO input or output is indeed in line, or no? Doesn't matter if it is hash, it is in line, or it is embedded. It will work fine, no problem. Or no, it has to be in line.
For my application, it has to be in line. When I'm generating a new game, I am making it in line. But for the subsequent moves, wait a second. This is something I didn't thought about. For the subsequent moves, I am checking. Yeah, it is. Yeah, it's there. Yeah, this function on output datum. So whenever, yeah, this thing. So I want the datum, not the datum hash. Yeah.
So output datum, yeah.
It's either three things: no datum, a datum hash, or the actual inline datum. So this is the V2 feature. So yeah, I am checking that.
But this is for output. I mean the inline. I mean the input.
Input is. I mean,
okay.
input. We need not bother. So only output. I mean, since the contract is working, that means we are having datum.
Yeah, but one of the things that I'm struggling now with the project I'm working on, thinking through how how can I filter out the incoming UTXO, because the incoming UTXO can come from anywhere. We don't have control over that. Someone can send that the Cardano CLI mistakenly or whatever.
Yeah.
Should we filter that out or no? Like getting input datum out of it. And if it is in line, then contract continue. If it is not in line, contract will throw an error.
Yeah, I mean, each of the UTXO, if it is spending something, it will have a datum. So I mean, I'm in a corresponding script. So like maybe it depends on the application whether it's needed or not. For mine, I mean, yeah, I mean, for mine, I did not find that need.
Great.
Yeah, so maybe somebody was asking something.
Actually, Lucas
Yeah,
was
some
very
yeah, some
question.
But yeah, I don't want to change the topic from here. I just if I just have 10 minutes and then I need to go as
Yeah.
well.
Yeah.
But are you done for today? Because my question is really dummy. It's just about wallets and Eternal and all that. Okay. So also I want to say congratulations, although I don't understand the contracts part, but just on the use cases, I think like Mix was saying, he did the great job with that use case, but apparently you've really done a lot more on the front end integration and all that. And if you give Mix something to think about, then I think we really stepped forward with this. So my question is really basic. Let me just share the screen. So I'm gonna share my desktop, and what I have there is so I do these sessions for non-technical people where I keep generating wallets, and I do that on screen. And so like I'm doing here, you know, I can just create the random
just a
seeds.
second.
Yeah.
Okay. Lucas, is it you?
Yes.
Oh, nice to
That's
see
me.
you.
Sure.
Let me see. I'm unable to wait a second. So I think I need to first disable my screen share, right?
Oh,
okay. I just stopped my screen share. Yeah, now I can see yours. Yeah.
Okay, great. So yeah, so like I was saying, I have these situations where I do these trainings for non-technical people, and then I create wallets, and I do this live, and because it's just testnet and pre-prod, I really don't care if they see my seed phrase, because it's just a burner wallet. But my situation today was really funny because I switched this wallet to pre-production, and when it had 5,000 test ADA, and when I got here, it got into a state where it was showing here an entry saying like external stake. And that was really odd for me. It felt like I thought, well, someone took my seed phrase and emptied the funds or something. But then now, because it's pre-production, it was respun or something. I don't know what could have happened. Maybe could it be that pre-prod was respun and my balance went away?
Yeah, I mean, I think if you have checked it after maybe say like 30 days, 40 days, because I think a month ago or so, a pre-prod got respun. I'm not sure about in few days.
Okay. Yes, Saurabh is right. But when did you check, Lucas, that you had the balance?
Just before today, as soon as I loaded the wallet, it had sort of like a cached amount of 5,000, and it immediately disappeared from this part, but started appearing here as a staked external. And that's what I never saw, that concept of external stake or something that Eternal was showing here. That's why I wanted to ask you if you know if that exists or if it's a thing or something.
And now
doesn't ring a bell. External
stake is gone. Now
yeah, exactly. So now
maybe
everything is gone.
can be seen transaction history. I mean, you can query your address in a blockchain, not in internal, in the blockchain. Like you can just copy
Cardano Explorer, Cardano Scan, somewhere like this.
Sure. Yeah. Okay, but you don't really know, you're not familiar with the concept of external staking. So my funds were here and weren't
not
here.
familiar. So yeah.
Okay.
You know, the reward is coming to the stake address. When you are delegating to a pool, your rewards come to the stake address. And when you withdraw the reward, you are taking from this staking key or stake address to the payment key or payment address. So it's like an internal transfer from two wallets, which you own, but both of them have different. But how they transfer from the payment address to a staking part, and now from a staking part to nowhere, that should happen.
Yeah,
you have to see.
It was really weird. But it probably was because of the network being respun. I'm just surprised because I wasn't sure if respinning the network was going to reset my balances or not. And also, for example, I have this one here that is older.
Sorry to interrupt. By the way, Lucas, like in your previous Eternal window, can you go to settings?
Sure. I'm using the single address mode.
Yeah, then I think we can just query your receive address, maybe.
Okay. I'm usually using that one. So another question I wanted to ask you is the stake key, even if I'm, especially if I'm working on mainnet for some reason to demo something, is this compromising or my address compromising at all to go to YouTube?
I don't think so.
Normally a stake key and the payment pub key have different private key and public key. So the address, what you see as stake key is an address, and this address is different, and these private and public key are different than your payment part. And when you see the receive, that receive, as I told before, that it consists of two parts, payment and a stake. So, and these two parts generated by two different payments, or let's say private key. So if someone compromise your payment or the payment part of your address, he cannot access to the stake part. And if he gets the staking part, he cannot get access to the payment part, but maybe he got both. Inside the wallet, something like this, you cannot see that. I mean, they generated by themselves and they are hidden and encrypted inside your system, inside your computer, inside your browser cache. It is not the cache, but should be in a storage. But in generally, that's the idea.
Okay. So yeah, let's maybe never mind this because it's completely. Oh, sorry. Actually, I didn't switch to pre-production, did I?
Yeah, that is what I was about to say.
Okay. Yeah. Yeah. Okay. Never mind. So you covered
the
this
whole
question.
address. Did you copy the whole address, the receive one?
No, I just used the.
Because that there is a payment part inside this one. I wonder what happened here.
Yeah. Nothing there. That's fine. It's probably the reset from respinning it. That's fine. So just to say it again, it's okay. You think if I'm using mainnet that I can show this on the screen and my receive address, no one can have access to my phone?
There is no problem with the addresses. We can show it on a stream and something.
As long as I don't show my seed phrase, that would be okay.
Seed phrase or your private.
Of course not.
Yeah, private keys. Even the public key, like if their verification key is fine, but the signing key is not fine.
Okay.
So because the seed phrases create a root key, and from that root key, I can send you the
so what you mean is even in this form or the hexadecimal or ugly form, I never show this one.
You never show the
obviously.
Yeah.
Okay.
Because that they can create because one of the things that I will try to tell to the people, the student in next iteration. First, for now, for the time being, we are creating very simple signing key and the public key, a verification key, and we will do all the transaction Cardano CLI in BBK. And I think that that's wrong. We need to talk about address more. So in next iteration, I'm going to first talk about how to interact with Cardano wallet inside your that's a command line with the Cardano wallet and generate a seed phrase, and from that generation, creating root key, and from that root key, an address pathway, which you can see in your address. There is if you go into Eternal, in your receive, you see there is
derivation thing.
Derivation, this one, and from this then you can generate payment or signing key and verification key, which we are doing that. So people can first import whatever they are doing in their Cardano CLI to their Eternal or to Nonami or whenever they want. For example, right now you cannot do that. You have just signing key and verification key inside the Cardano CLI, and you cannot import it inside your Eternal or Nonami.
So how would you import it into Eternal?
Exactly. If you want,
you can generate the seed phrase.
First seed phrase, then this kind of pathway and address, and then payment part, which is the by payment I should say that the signing key and the verification key. So the two key that you're normally using in Cardano CLI. And the verification key is the pub key hash, and the signing key is private pub key hash, which is CBOR and so on. So, you know, there is a S key and V key, if you remember.
Yes. I have that somewhere in my
S key and
VS Code.
You cannot create a seed phrase from that S key, which is your private. And you should not share that. But you can create S key from your seed phrases. So that's the thing that I realized that we did.
Okay, so the seed phrase is going to be a precursor to the
whole
S key and
process.
V key.
Exactly, the whole process, the seed phrase.
And so, and after all of this, in the beginning, I mean, you're actually going to use some just a random seed phrase generator. Is that it?
Which is Cardano Wallet. IOHK already created that tool. The Cardano Wallet.
I was noticing the other day that Mesh can do that as well. It can randomize seed phrases.
Yeah, that's good too.
But that's different. It's because it starts at the seed phrase level.
I think that's I don't know, for guys like Surab or anyone that who's good in the front end, the process is clear for them. They can look at that and see how they are driving different step of these stuff from that seed phrase. But I think that it was missing inside BBK.
See there?
Yeah, exactly. So first, and the question, how can you create that in Cardano CLI? And then after that, how can you create a signing key and verification key from that? So then you can import your wallet whenever you want. You can use this tool. It doesn't matter. I mean, I think I have the command somewhere where I can post it here. So you can just check it. The command. It's one line command.
Oh, you have something here as well. Cardano CLI generated keys. Yeah, they have a lot of stuff.
Well, I use the Cardano wallet for that purpose.
Okay, sure. Thanks. So very last question. Is testnet still usable? Do you think it's still okay? It's not going to be reset or switched off?
Or no, the old testnet is gone. You shouldn't use it. It's like a dead blockchain.
But I know, but is it still working?
No,
it's just for demos, because this software I use, the Game Changer, is only available on old testnet, and I have some fun things to do with my learners here.
If there are nodes for them that they are producing the block, yeah, it works. But if there is any block producer, which we call them node, Cardano node, yeah, that's a dead blockchain.
Yeah. Okay, but as far as I can see from here, it seems to still be running.
So yeah, someone is still running the old blockchain inside there.
I still have 20 million Lucas coin.
Yes. Interesting.
Yeah. So this is just something that I like to do with the learners, because we play around on the test nets and they don't need to, get relayed or something. We create whatever we want. Actually, I learned a bit of this from James in one of the sessions, or Curtis, I think, who was using Game Changer to demo things, and I really think it's nice to use with the learners.
I don't know. Did we put Game Changer inside the BBK? Because in the first iteration, it was about Game Changer and that the teacher.
Oh, maybe it was not. It's not there anymore.
Oh, okay. So that's old material.
I'm not sure.
The first generation I was in that they were teaching the NFT and how to mint it and how to do stuff with Game Changer Wallet back in February, March, April.
No, this for me was June, something like that. But yeah, I need to go over this from top to bottom again anyway.
Great.
I have a lot to learn. Okay, guys, thank you so much. Sorry I kept you for a while.
No, thank you.
I'm gonna
Thank
hop
you,
into the
Suraj.
global catalyst.
Oh, great. So see you guys and
Okay.
thank you again. Take
Yeah,
care.
see everyone. Thanks for
Bye.
coming.
Thanks everyone. Bye-bye.